Hello students, good morning and welcome to class again. It's morning here, so good morning. How are you doing? I hope you've been coping very well with the classes. Please try as much as possible to do all that you can to get the best of it. I wish you all the best. All right, so in this class, we'll be looking at a topic in chemistry for SS2. So far, so good. God being gracious. We've talked about several topics in chemistry for week 1 up to week 8. So in this particular class, we'll be looking at week 9's topic. And that topic is, you'll see it shortly. So it's chemistry for SS2 and it's week 9's topic. So we are looking at the topic we are looking at is unsaturated hydrocarbons. So we've talked about saturated hydrocarbon, and in the last class we actually talked about unsaturated hydrocarbon, and our focus was on the alkenes. So in this class we'll be looking at the alkynes and aromatic hydrocarbons. These are the ones we are going to be looking at in this particular class. So let's look at our learning objective. Number 1, should be able to state the general formula of the alkynes, mention the first few members with their molecular formula. Please pardon me if I'm not actually pronouncing the word alkynes correctly, but what we are looking at is the hydrocarbons which ends with YNE. So remember we said that hydrocarbons are compounds of hydrogen and carbon alone. So carbon and hydrogen alone are hydrocarbons. So we've talked about the saturated one, which is the alkanes, ANE. It ends with ANE. So we talk about the alkenes, which is ends with ENE. Then we are looking at the alkynes now. So now we are going to, so you are going to be able to state the general property of the alkynes, mention the first few members with their molecular formula, write the iopackness and structure of simple alkynes, describe the laboratory preparation, properties and uses of ethene. Ethyne, not ethene, ethyne. Then describe the test for unsaturated compounds, write the structure of benzene, and state the properties and uses of benzene. Those are what we are learning in today's class. So let's look at the alkynes generally. Remember, we said that unsaturated hydrocarbons are hydrocarbons which contain at least that contain at least one double or triple bond in their structure. So the alkynes are unsaturated. They are homologous series of unsaturated hydrocarbons with triple bonds. So remember what homologous series are. They have general formula. They follow general formula. They are prepared generally by the same method. They are just a little graduation of their physical properties. For example, few members are gases, so as you move down the group, you have some are liquid, then moving even to the larger molecules, they are solid. So alkynes are homologous series of unsaturated hydrocarbons with triple bonds. So they have triple bonds. Their molecular formula, their general formula is CnH2n minus 2, where n is a positive whole number greater than or equal to meaning that there is no alkyne with C1. So why? Because of so that the triple bond can be positioned. So those are alkynes. They have triple bond in their structure. Now, the alkynes have high degree of unsaturation because of the triple bond. They have high degree of unsaturation than the alkenes, which have double bond, and so they are chemically more reactive than the corresponding alkanes and alkenes because of their electron-rich triple bond. So their triple bonds are very rich. So that's what makes them very, very reactive. So now let's look at some of the few members of alkenes. Now, number 1, you have ethyne, which is molecular formula. Sometimes you call it acetylene. So you have C2H2. Now, from the molecular formula, which we said is CnH2n minus 2. So let's look at that. N is 2. So 2 times 2 is 4, and 4 minus 2 will give you 2. So that's why the molecular formula is C2H2. And that's the structural formula, condensed structural formula. You have C, you have 2 carbon atoms and hydrogen atom. Remember that every carbon atom is has 4 bonds. So if you look at this carbon, you have 1, 2, 3. Then this hydrogen makes it the 4th bond. Then for this carbon, you have 3 bonds, and then this makes it the 4th bond. So that's ethyne. Yes, ethyne. Then, thank you, ethyne. So we have propine. Propine is C3H4. That's why 3 times 2 is 6, and 6 minus 2 will give you 4. So that is the structure. Then you have but one ine, or 1 butane, which is C4H6. So we have C. You see that the triple bond is on carbon 1. Then in this other case, you have 2 butane. So you have the double bond on carbon 2. So you have the other one. Now, if you look at this molecular formula of butane, you have C4H6. 4 times 2 is 8, and 8 minus 2 is 6. That's why you have C4H6. 4 carbon and 6 hydrogen. Then pentyne, you have 1 pentyne and the rest of them. So these are the first few members of alkyne. Now, the first 3 members of alkyne, that is ethyne, propine, and butane, are gases at room temperature. You see the gradation in physical property. The next 8 are liquids, while the higher members are solid. So these are the general characteristics of the alkyne. So now let's look at IUPAC nomenclature. We've talked about IUPAC nomenclature in the last class. By now, you should be very familiar with them. So look at this. This is ethyne. Why? Because it's 2 carbon atom, and then you have triple bond. So with triple bond, the name ends with YNE. So this is propine. This is propine. Don't say propane 1 I. No. Why? Because whether you put the triple bond here or you position it here, it will end up to be in position number 1. It cannot be in position number 2. So it is propine. Now you need to know how to complete the bond. So here you have 1, 2, 3, 4 to this carbon. To this carbon, you have 1, 2, 3, 4. So this particular carbon has no hydrogen attached to it because it is complete. So you have 1, 2, 3 here, and the hydrogen completes it for the terminal carbon that is there. So that is propine. Then next one, you have but-1-ine. Why? Because the triple bond is on carbon 1, so we are counting from the right to left. So we have 1, 2, 3, 4. 4 carbon is but, and we have 1 ine. Then look at this example. We have pent-1-ine. Why? How many carbon atoms do you have? You have 1, 2, 3, 4, 5 carbon atoms, and then you have, so it's pent, and the triple bond is on carbon 1, so you call it pent-1-ine. Now, again, just for you to help you really know how to complete bonds. So looking at this, you have this carbon has this bond, right? So to complete it is lacking 3, so you have 3 hydrogen to complete it. So this carbon, you have 1, 2, and you have 2 hydrogen completing it. So this carbon, you have 1, 2, and you have 2 hydrogen completing it. So this carbon, you have 3 bonds here, 1, 2, 3, 4, making it 4 bonds. So there's no hydrogen attached to it. And then to this terminal carbon, you have 1 hydrogen completing it because you have 3 here. So that's pent-1-ine, and here you have pent-2-ine because you have 5 carbon atoms, 1, 2, 3, 4, 5. Now counting, remember you give the smallest number to where the triple bond is. So we have 1, 2. So we counted from the right to the left. So I have 1, 2. So the double bond, I mean the triple bond is on carbon 3. So that's why it's pent 3, pent 2 ion, sorry, pent 2 ion. But here, if you had counted from the left, it would be pent 3. So that number is larger or bigger than 2, so you use 2. 2 is acceptable. Then coming here, look at this one. You have 1, 2, 3, 4. So now the double bond is on carbon 1. So this is actually and you have a methyl group on carbon 3. So the name is 3 methyl 1 but 1 butane. So the actual name is, this is also acceptable, but the actual name is 3 methyl but 1 ine. So that is the IUPAC name of that compound. So let's take that example. You have this, good. You have this now. You see, for the sake of you to understand it better, I had to do this again. So you have, look at this, you have how many carbon atom is the longest continuous chain? 1, 2, 3, 4. So, and you have the triple bond on carbon 1 and the methyl group, that is the substitute on carbon 3. So you have 3 methyl but 1 ine. Then look at this. Now look at this very carefully. Count the number of carbon. 1, 2, 3, 4, 5, 6 carbon atom. Then now I'm counting from the left because the triple bond is on is on the left hand side. So you have 1, 2, 3. So on carbon 3 you have 2 methyl group. So you have 3, 3. Then on carbon 5 you have another methyl group. So you have 3, 3, 5 trimethyl, 3 methyl group. So you have 3, 3, 5 trimethyl has 1 ine. That's the name of that compound. Then look at this. So let's look at this. Let's count from the left. 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 odds. Now, if you had counted from the right, it will be 1, 2, 3, 4, 5. 5 is too far compared to 3. So we are taking from counting from the left hand side, and then there is a substitute on carbon 7. So the name of this compound is 7 methyl ot 3 ine. That's the name of this compound. Good. So that is for nomenclature of alkynes. So next thing we are looking at, let's take a particular. Remember I told you that once we can study a particular one, we can also relate such their properties, the property of one to other members of that homologous series. So ethane is the first member of the alkyne series with molecular formula C2H2 and structural formula C triple bond, that is hydrogen attached to that carbon and another hydrogen. So this is the structural formula. Now in the laboratory, ethane is prepared in the laboratory by the action of cold water on calcium carbide. So this is the reaction. This is the reaction, equation of reaction. You have calcium carbide react with water and will give you calcium hydroxide and ethane, which is the product we are looking for. Now, in the preparation of our ethane, it is prepared in sand. Why? Because this reaction produces a lot of heat. So a lot of heat is being produced. So for the vessel which it contains the calcium carbide, so that it will not break, it is reacted in sand to avoid the heat or the amount of heat that is produced during this reaction from breaking that container. So it's reacted in sand. So now again, so when the reaction happens, it is passed through acidified copper 2 tetraoxosulfate, copper 2 triazocarbon, copper 2 tetraoxosulfate 6 solution to remove substances like phosphine. That's the major impurity. Phosphine is pH 3. So to remove that impurity, it is passed over acidified copper 2 tetraoxosulfate 6, so that at the end of the day you have your ethyne, which is also known as acetylene. So, and you have your product. That's the laboratory preparation of ethyne. Then now, physical property of ethyne is that number one, it is colorless, the colorless gas with characteristic sweet smell when pure. It is colorless. Then it is spirally soluble in water and slightly less dense than air. That's another property of ethyne. Then ethyne is unstable, meaning that it's very reactive. Remember, it has triple bond, so that makes it very reactive. Because of that, it is stored by dissolving it in propan. So it is dissolved in propan. So because it's very soluble in water, so it will dissolve in propan when stored. Okay, now chemical properties of ethyne. Ethyne bonds in air. Sorry, there's a mistake in that thing. Ethyne bonds in air. So it burns in air to give a very smoky and luminous flame. So because of the presence of that triple bond, it will give a smoky flame. And so you have product. Remember that all carbon-containing compounds bond in oxygen to give up carbon 4 oxide. So it's sufficient oxygen to give you carbon 4 oxide. Right there, you have your equation. Then another reaction is that most reaction of ethyne is addition reaction. We talked about addition reaction in our last class. Addition reaction is when there's the double bond, the unsaturation are broken. So addition reaction happens. So ethyne will react with other substances. So due to their unsaturation, so due to the high degree of saturation, it readily undergoes addition reaction. For example, it reacts with hydrogen in the presence of nickel and at 200 degrees centigrade. So the reaction is of 2 stages. Addition reaction in ethyne is of 2 stages. One, the first stage is that the ethyne will be broken down to ethene, and then the ethene will now be further broken down to give you ethane. So you have ethyne react with hydrogen in the presence of nickel to give you ethene. Then further, it will react with hydrogen again to give you ethane. So this is stage 1. Look at another example with halogens. So the same thing, 2 stages of the reaction with halogen. For example, you have bromine. Bromine will react with ethyne to give you CHBRO, and then further react again. That is, the name of this compound is dibromoethene. Then why here? You can call it 1,2-dibromoethene. And here, so it will further react with more bromine to give you 1122 tetrabromoethane. Now, in this case, you see that the double bond, triple bond was broken down to double bond, and then double bond now broken down to single bond. So in each stage, the same thing with hydrogen. The triple bond was broken down to double bond, and then double bond now broken down to single bond. The same thing with halogens. Then with hydrogen halide, ethene will react readily with hydrogen iodide. When we say hydrogen halide, that means hydrogen and a compound of hydrogen with hydrogen with halogens. So hydrogen iodide is a hydrogen halide. So it reacts readily with ethene at room temperature. So you have the product. So in this one, the hydrogen will so it will attach to this substance. So you have iodoethene. Then further, it will react with this iodoethene to give you diiodoethene. Now, in this reaction, there's something you need to understand about this reaction. When alkynes react with hydrogen halide. Now, what happens is that they attach themselves to the hydrogen in the second stage. In this second stage, this hydrogen attaches itself to the carbon with more hydrogen. For example, in this second carbon, there is 2 hydrogen, while in this first carbon, you have the iodine and 1 hydrogen. So this hydrogen in this second stage will attach itself to that carbon with more hydrogen, while the iodine will now attach itself with the one with less hydrogen. Let's take example. For example, look at what I said. I say in the reaction of benzene as well as other alkynes with hydrogen halide, hydrogen is added to the carbon with the greater number of hydrogen atoms, while the halogens go to the carbon with less hydrogen atoms. So in this case now, you have this substance. This is but1 ion. So but1 ion, when we have to say hydrogen chloride. So you have the chlorine will go to this carbon without hydrogen atom. So you have the chlorine atom attached to that carbon, and then the hydrogen goes to this carbon which has hydrogen already with the greater number of hydrogen. Then in the second stage as well, the chlorine goes to that carbon again that has less hydrogen, and the hydrogen goes to that carbon with more hydrogen. The same thing with is this when you react hydrogen bromide. When you react hydrogen bromide with this but2 ion, so you have sorry, let's correct that name, is in. Good. So you have the bromine will be attached to the carbon with less hydrogen, with the one without hydrogen. Then in the second stage, the bromine will still be attached to the carbon without hydrogen. So this is the rule that governs the reaction of alkynes with hydrogen halide. Now, in the reactivity of the hydrogen halide with alkyne, hydrogen iodide is more reactive with them than hydrogen bromide, and hydrogen bromide is more reactive with the alkyne than hydrogen chloride. Those are the order of reactivity. Then uses of ethyne is that one in combination with oxygen. Remember, they burn in oxygen, and so it produces to produce carbon dioxide. So ethyne combined in combination with oxygen produces large amount of heat, which is used, and that flame which produces is used in cutting and welding of metal, like you see in this image here. So it's in combination with oxygen, you have a large amount of heat is produced, which is used to weld metals and to cut metals as well. Then another use is that it's used in the manufacture and synthesis of products, like what you have here. You have PVC, polychloroethylene, used in making plastic. You have neoprene, artificial rubber. So these are the uses of ethylene. Then ethylene is also used in certain labs like miners lab and hunters lab to produce light. So it's used as fuel in them. So you see this example this is an example of a miner's lamp. So the fuel that is used is actually ethyne. So that's what is used in making this miner's lamp to light up. So now tests for unsaturation. In testing for unsaturation, remember that unsaturation in hydrocarbon means there is presence of a double or triple bond. So usually we are looking at testing for, if for example you have a substance in the laboratory, you want to test whether it is a saturated hydrocarbon or unsaturated. You can use bromine water. Now bromine water is orange in color. So when you add it to the substance, if it is saturated, the bromine color, that's the color of bromine water, will remain unchanged, like what you have here. This saturated, no double bond, so or triple bond, you have this color. The bromine water color will be obvious there. But if there is presence of unsaturation, that means the presence of double or triple bond, the color of bromine water will change from orange to colorless. So it means it decolorizes unsaturated hydrocarbon, decolorizes bromine water. Another test that can be used is also copper potassium tetrahydromanganate 7. It also decolorizes in the presence of unsaturated hydrocarbons. But the problem with this test for potassium the problem with potassium tetrahydromanganate 7 is that it's also used to test for reducing agent, and they give this same they decolorize. Reducing agent decolorizes potassium permanganate, which is potassium tetrahydromanganate 7. So they decolorize potassium permanganate. So to actually test for unsaturation, you use bromine water. But a saturated hydrocarbon, the color will remain unchanged. So for bromine water, the color will remain orange, and for potassium permanganate, the color will remain purple. So now, to distinguish between alkenes, that's double bond and triple bond hydrocarbon, you use ammonical solution of copper 1 chloride or silver triethylnitrate 5 is used. So now the alkynes will give reddish brown precipitate with copper 1 chloride. Copper 1 chloride is Cl. Copper 1 chloride is Cl. Copper 1 chloride is Cl, and so I've corrected that. Now, so it will give the color that it will give will be reddish brown with copper 1 chloride, while with silver triethylnitrate 5 it will give whitish yellow color. So alkynes we give reddish brown color with copper 1 chloride, and give whitish yellow color with silver triethylnitrate 5. Hope we are following that. But if you react the alkenes with this substance, there will be no reaction. The color will remain unchanged. So now, but most especially, you should know that all alkynes with terminal triple bond. For example, let's go back to something. Let me explain it. Now, this is a terminal alkyne. Why this is not terminal? When we mean terminal, the triple bond is at the terminal carbon. But this will not give a positive test with ammonical solution of copper 1 chloride and silver triethylnitrate 5. Hope you understand this. Please, if you have any question, ask me or go back to the video again. You will understand. By the time you play it twice or more, you get a better understanding. So what I'm saying here is that bromine water and potassium permanganate is used to test for unsaturation. But to distinguish between alkenes and alkynes, remember both of them are unsaturated. We use ammonical solution of copper 1 chloride and silver triethylnitrate 5. Good. So, and I said again that in this case, this substance will actually give you that color with terminal alkynes. That means the alkynes that have their triple bond at the terminal. Good. So now let's look at aromatic hydrocarbons. Aromatic hydrocarbons are benzene and benzene compounds. That means compounds that resemble benzene. So they have ring structure and they have characteristic pleasant aroma. Now, benzene is mainly obtained from the destructive distillation of coal. Benzene is the most important compound in this aromatic hydrocarbon, although others are important, but benzene is other molecules follow the benzene structure. Now, one thing about benzene you should know is that it's actually, you see, in most structure that you see in benzene, you see in this case, you see it has alternating bond. It has alternating bond. Now, you see, this structure is equivalent to this. Look at this case. You have the double bond here, you have it here, and you have it here. Now, it can also be represented that the double bond is now here, here, and here. In actual sense, if the double bonds are not static, meaning they are not stable in that position, they are actually rotating. That means they are actually rotating. So this bond or this characteristic of benzene is known as resonance. So the double bonds are not actually static or in a position, but they are actually revolving around the molecule, around the 6 carbon atoms of benzene. So this is known as resonance, like I said. So the structure of benzene can be represented as this, or this. So you see in some structure, you see this hexagon, a hexagonal shape, something like this, with the alternative double bond here, alternative double bond, or you see it like a cycle. That means showing you that the bond is actually rotating. So this is the structure of benzene. Now, physical properties of benzene. Benzene is colorless, it's a colorless volatile liquid. Volatile means that it actually vaporizes easily with characteristic sweet smell. It is insoluble in water but soluble in ethanol. So it is non-polar, so it's not soluble in water. So it boils at 80 degrees centigrade and freezes at 5.5 degrees centigrade. These are the physical properties of benzene. Now, chemical property. Benzene is highly flammable. That means it readily burns. So it burns in air with a smoky flame. Remember, it's very unsaturated. So it burns with a smoky flame to give you carbon dioxide, which is always the product of carbon-containing compound. Then benzene undergoes substitution reaction. For example, you have benzene. This is benzene. This is the structure of benzene. I told you that you can represent it in several ways from what I showed you. So it reacts with chlorine. Then one of the hydrogen in that benzene is substituted with the chlorine atom. So you have Cl. So this is chlorobenzene. And then you have HCl. Now, another thing is that benzene undergo addition reaction. Benzene, that's another reaction that goes. For example, it reacts with hydrogen gas in the presence of nickel catalyst to give you cyclohexane. Remember, cyclohexane is saturated, so you have cyclohexane. It can also react with chlorine in ultraviolet light, in the presence of sunlight or ultraviolet light to give you this substance. This is known as 1, 2, 3, 4, 5, 6 hexachlorobenzene, or what we call benzene hexachloride. So these are the products of the reaction of benzene. Now, uses of benzene. Benzene is mainly used as an organic solvent. You can use it in the production of dyes, pharmaceutical drugs, lubricant, because they have cleaning properties. It can be used in paint remover, e.g. thinner, rubber is used. It can also be used in making polymers, substances which can used for producing shoes and tires, aftershave lotion, and I told you that it's a very good solvent. Then benzene helps. It's also used as an additive in fuels in petrol to reduce the anti-knocking property of the petrol. So it's also used as an intermediate to produce other chemicals. So that's the uses of benzene. So this is where we are ending the class for today. I hope you got something. Please try as much as possible to play the video 2 or 3 times to get a better understanding. And if peradventure you didn't understand anything, please try as much as possible to send in your question and I will answer you as soon as I get them. So go to the school website, the notes is uploaded there and it's for week 9. And for further studies, you can use New School Chemistry by Ababio, then Exam Focus Chemistry by Orgia, and then Practical Chemistry by Akin Tolu. You can use that to help you understand better. So this is where I'll end the class for today. Thank you very much for listening. Keep staying safe and God bless you. All right then, bye. Until I come your way next time.